So, hello, I'm Arlene Ducao,
And I'm Ilias Koen.
and we are the principals of the DuKode Studio based in Brooklyn, New York. Thank you to Create Lab for hosting us and our workshop here today. The DuKode Studio specializes in scientific visualization. Ilias and I have a collaborative history in large part at the American Museum of Natural History. And we first met when we were students at the School of Visual Arts. We were taking physical computing classes. And so those are sort of the two main pursuits of the DuKode Studio, scientific visualization and physical computing software type endeavors. And what we're going to talk about today is how to combine different kinds of mapping data to potentially find correlations, unexpected correlations. And we thought this was interesting. One, as part of this larger festival that we're participating in, called the Conflux Festival, which is here at NYU. And it's a festival of psychogeography. So a lot of the events here at Conflux are exploring downtown Manhattan in sort of artistic, unusual ways. And a lot of those projects are collecting data through GPS. And so there are a lot of mapping projects going on right now, you know, with Google Earth, that kind of thing. Mapping has become such a large part of a lot of people's everyday lives. And what we thought would be interesting would be to combine a lot of some of the GPS data sets that are floating around in the ether with some of the more satellite-oriented data sets that a lot of map professionals and enthusiasts use to analyze and predict aspects of the climate, of the geography, of topography. And in addition, there's another layer that we wanted to experiment with as well, the kind of political boundaries, the zoning, you know, like city zoning layers. You know, so what we want to do today is mash up these three kinds of data sets: the GPS crowdsourcing data sets, the infrared satellite data sets, and the political zoning boundary data sets, and see what we come up with. What we're going to give you an overview of the tools that we're going to use today. Our primary tool for this work is called Quantum GIS, or QGIS, which is an open source software that anyone can download. That's why we use it. A lot of mapping professionals use a program called ArcGIS, and so what we use is an open source version of that. This program I think is nice to talk about as opposed to bringing this data into Google Earth, which we could do, you know, or fooling around with it in Photoshop, which we could do for today, because it sort of lies at the intersection of what you can do creatively and what you can do at a more, I suppose, a consumer level. You can use this particular GIS tool for not just mapping aspects, but you can make really creative type projects with it. So that's what we're going to go into today. So Ilias is going to start off by talking about QGIS and then also talking about the satellite data that we use. And I'll pass the mic to him.
Okay. Hi. So we decided to use, there are like a couple of satellites that working at with, you know, geographic information that we are used to using, and all of them kind of vary in resolution and in wavelength that the data set provides. For this purpose, we're going to use Landsat 7. I think it's Landsat 7. Landsat is a program that was initiated by NASA early 60s, late 70s, with main objective to collect geographic information for Earth, for the Earth sciences. So all of the data are readily available. You can just download them, select the bands, and make different. So the instrument, I guess I should talk a little bit about the instruments that they're here.
Do you want me to turn the lights on?
That will be okay.
Yeah, sure.
So the main bands that are available are like 6 bands, which each of them refer to a specific wavelength spectrum that the satellite detects and separates into a different channel. So when we talk about band, we're really talking about like one grayscale raster image that we download and then we have. And after that, we can compile each image as an RGB. So assigning each band to a specific red, green, or blue value, thus ending up with a true color or false color, as they call it, because it doesn't really represent the visible spectrum.
So each satellite, there's the Aster satellite, there's a Landsat satellite, and another source satellite. Oh, I guess sorry. Another satellite source that we often use is a MODIS satellite. The MODIS takes the lowest resolution but the largest images. So for the MODIS, you would have, say, I'm not sure of the exact number, but for the MODIS satellite, you would get 100 images to make the whole Earth. For the Landsat, you would get something like 1,000 images, and for the Aster, you'd get something like 10,000. You know, so it's sort of like different magnitude, orders of magnitude. And each of these satellites has several infrared sensors, basically, and each of these infrared sensors detects a range of wavelength range. So that's what Ilias is referring to when he's talking about bands. So band on the Landsat satellite, which has 7 infrared detectors, band 1 takes the longest wavelengths, sense the longest infrared wavelengths, and band 7, I think, senses the narrowest wavelengths. I think that's correct, right?
Yeah.
And so that's what you're seeing here in this chart.
So in order, for example, if we want to compile an image that is true color, we will assign number 4 to the red, number 3 to the green, or number 2 to the green, and then number 1 to the blue band of the RGB composite. Another extremely cool element is like you can actually track those satellites and see where they are. And the way they capture the image is really the capture, it's very much the work with the principle of a scanner. So it captures like one pixel, and as it moves around, it compiles this continuous stream of images. And then the next step would be to actually process and reproject the data into the map that you want to construct. So you will need to assign some different geographic, how would you projections, I guess,
Yeah.
to the raster images that you end up downloading. And now we're on the QGIS, which is an open source GIS software. We have already downloaded our bands. So for example, I will just import
Do you want to show the
Fun.
Landsat website?
3.